Hey everybody, welcome to the live stream, which is currently live right now. What's up? It's your boy, M Spitz, coming at you live. The greatest streamer of all time that ever was, and certainly ever will be. So, uh, you should feel blessed. Hashtag blessed. Okay, so we can sort of look at some stuff. Um, and do some stuff. Sorry, I just wanted to hide that nonsense there. This is a little, I'm gonna move this over and then maybe make it a little bigger for fun, just for fun. That was pretty fun. Okay, all right. So if you have specific questions, happy to look through those, but hopefully the page that I'm looking at looks kind of familiar to you. If it doesn't, I think you've got bigger problems than this live stream review right now. I will have you know that there is, in fact, a smoke detector going off, chirping in the background of my house somewhere. So if you hear that, just know that I also am aware of it. Um, There it is. Yeah, right on cue. Maybe I'll handle it at the intermission. Okay. Anyway, so is it live? Is the face cam making this better? Totally making it better? Yeah, thought so too. Uh, no, I know I need new batteries. I know. Troubleshooting. Thank you. Anyway, so the idea is if we look at what we got so far, right? If we're looking sort of through our of course documents here, of course under notes is our Unit 4 folder, and then under Unit 4 folder is a whole lot of awesome, delicious stuff for consuming knowledge into our brains through our faces. Okay, so obviously the study guide is here. I actually pulled that up already, right here. So again, hopefully we took a look at the study guide already. 3 likes isn't really enough, so guys, like it. Come on, is it down? Probably like, wait, here? I don't know. Is it over here? Just follow that. Boom. Okay. Anyway, so as far as the study guide goes, I'm just going to sort of walk through again, give you an idea of the things that we talked about during, just because these are broad categories and sort of maybe some stuff. And then if you have any questions specifically about concepts that we talked about through any one of these, we can jump into them. I'll probably gloss over some of them, not to belittle their importance necessarily, but to uh, like again, study vocabulary for Blown to Bits Chapter 2. I'm not going to read the vocabulary to you, so you know, just you can do that. I believe in you. I believe in you. Um, so you can do that. You can study that. OYO. Um, okay, so far, PR. Again, the questions of what do we need to know, is this going to be on the test, how is this going to be asked on the test, are things that I probably won't answer or respond to. So I'm not ignoring you. I read it. I just don't want to answer it. So, wait, is that worse? Or I don't know. Either way, I'm not going to answer the questions of what's on the test. Um, if you want me to go through these step by step, I certainly can. I can answer the questions first, maybe, and then go through them if that's better. Yeah. Okay. So if we go to App Inventor, I mean, I guess I can show you some stuff on App Inventor. I can't actually show it running like on the screen. I don't have that really set up for that. I don't have the thing. You know what I'm talking about, the thing. So if I just go to MIT. Oh, I would again. The first thing on there is definitely the first thing on the list is Code HS. Again, you should definitely go to uh, Code HS and check that out. Um, just review what we went through, and again, I'll go through the sections a little bit if there's something that you want to go over, but yeah. Yeah, I definitely will cover procedural abstractions, again, what they are, and again, I might have it in this one right here. No. Okay, so let me see if I can find one that uses it. Logo, do we do it on P9, period 9? Probably. Okay. So the idea, again, remember we basically started with this where we had the Android guy and you can go forward, you can go right, you can go, okay, that's the pen up or down. We have hide or show, and then we have draw. The draw button was supposed to do something. So we have all these procedures. So this is just like, um, okay, I better write down what I'm doing in order. So again, I see questions about procedural abstraction, so I'm going to talk about that, right? I'm going to talk about that. The idea behind procedural abstraction, okay, is essentially to take things, right? Uh, to take some sort of instructions, okay? And so abstractions are basically making things simpler, right? They're taking something and making it simpler. But how are they making it simpler? Well, in our case, they're making it simpler through abstraction. I mean, through a procedure. That's why it's procedural abstraction. Abstractions make things sort of simpler. My chair is squeaky. Um, and so we're making it simpler. So if I'm looking, like, for instance, again, let's see. I have some of these collapsed and other ones I don't. Okay, so here's the main one, draw face, right? So we did all these other ones, which we'll come to. But if you'll notice, like, they're done. I can sort of just take a look over here. Come on, why isn't that grabbing it? I don't know why I can't grab draw rectangle, but weird. I don't know. Now I can. Okay. So again, this is when I am looking at when I click the draw button, what happens? One thing happens. Draw face. That's easy to read, right? I mean, that's the idea, is that it's easy to read. I know exactly what that's supposed to do. Um, it's also making it so let's say I wanted to draw 10 faces, right? Well, instead of doing literally all of these blocks, right? Because these blocks together do this, right? I mean, this is representing like a ton of things. It's drawing eyes, drawing the nose, drawing the mouth, drawing the head, right? But the head is drawing a square, the eyes are drawing two smaller squares, the mouth is drawing a rectangle, and the nose is drawing a triangle, right? So it's like drawing, I don't know how many things I named. I draw some things, right? So it's drawing those things, and but it's all that code. So if I wanted to draw two faces, instead of copying and pasting all of that code in one giant long block of code, I'm just going to package it up into a procedure called draw face, right? Into this one over here, right? So this right here, right? So I'm just packaging it up into that. And now it's pretty easy to deal with, right? And so the idea is that if I'm like thinking about procedural abstraction, like why is that good? Like what did that even do? Like, well, I mean, it did a couple things, right? I mean, that's kind of the beauty of it, is that procedural abstraction does a few things. It simplifies the code. It's much simpler looking, right? All this is, I can collapse all this and I can just let it all be up here, sort of, off being done. It's just that's what it does, right? It simplifies the code. Okay, but also I know that all the code for drawing a face is all contained within this one procedure, right? It's all contained in here, right? Because when I call draw face, it's actually calling. Uh, did I already move that? Draw face. There it is. It's calling this procedure, which then is broken up into other smaller procedures, drawing head, eyes, mouth, nose. So it's doing those four things. So it's condensing the code together, right? It's simplifying it because it's easy to read. Even these are easy to read. Like all these are examples of procedural abstraction because I'm making a procedure to do a task. That's procedural abstraction. That's an example of it. Again, why is it good? Why is it actually useful? It simplifies, right? We know that it simplifies this code, makes it easier to read, makes it easier to debug. That's all part of simplifying, right? It encapsulates the code. Well, it keeps it all together, right? I know all my code is together. Encapsulate means, like, again, we're taking all the code about drawing a head, or drawing a face, right? And we're condensing it into one area so that I know that whenever I need to draw the face, it's in that area of my code. I know where it is. So that's encapsulating the code, keeping all the like code together, and then um, I don't know about you guys, but I think my hand motions are really adding to this presentation here. I'm just saying. Um, like if you agree, don't dislike if you don't agree. Okay. Um, if you so it's encapsulating it all. It's keeping it together, sort of, and it's all the light code sort of together, right? And then it's also, let's see, talked about simplifying it, making it easier to read, easier to debug, easier to use. That's simplifying, encapsulating, keeping it all together, and also it's condensing. It's making it smaller. And again, because if I wanted to draw 5 faces, I wouldn't have to copy and paste all this code all over again, right? Everything in all of these, like this is all this happens when I draw the face. I don't know why that's okay. Expand. All of this is happening when I call that one thing, right? When I draw a face, all of that's happening. I don't know, not that one actually. But all of these, right? All of these are happening. So it's like instead of copying and pasting and doing all that and then trying to figure out maybe there's an error, maybe changing, modifying a little bit of it. Nope, I don't have to do any of that. I just call it twice. Boom, it draws 2 faces. Draw it again, draws another face, right? So the idea is that it condenses the code. It makes it so I only have to show the procedure one time and I can reuse it over and over and over again. Simplifies, encapsulates, and condenses. Is that a pretty thorough explanation for uh, again, encapsulating is keeping it together. Is keeping the code. Again, remember these are all like benefits to this. So yes, there's some overlap to them, but the idea is the benefit of abstraction in general, but more specifically procedural abstraction, is taking the procedures, bundling them up, and that so that I know that they're together. So whenever I need to know anything about drawing the eyes, guess where I go? It's right here. It's all together under this draw eyes procedure, right? It's encapsulated all underneath here, as opposed to drawing the nose. Well, here it is, right? Oh, how do I draw a square? Well, here it is. It's just drawing a rectangle with 2 sides that are the same, right? So the idea is that like it's encapsulating by keeping the code together, so I can find it and check it and debug it and things. But as far as condensing goes, it just means there's less code overall. Like my code goes from like, you know, hundreds of lines of code. If I was copying and pasting all of this code, right, all of that. I'm really bad at figuring out where to point. That code right there, right? All of that code. It's like instead of copying and pasting all over again, I have it one time, and I can just call that one procedure that does all that. So it's making like fewer lines, in our case blocks, but fewer blocks of code, through fewer lines of blocks of code. Okay, so that is procedural abstraction for Isabella and Hannah and Miles. Okay, so we got those down. Now, uh, the next one was while I'm in App Inventor, I'll do the ones that I can sort of show. So that would be clock. Maybe I can show those things, but the clock is another one. Are we okay with that? Me showing how the clock works. Um, well, how the clock works. What you can do is you can actually see it right here. See, guys? It's right down here. So yeah, it's a clock. Ha ha ha. It's not. I was talking about this. There we go. It ruined my joke that I moved myself, but there it is. Okay. Anyway, dumb jokes aside, people. Um, here we go. That's not really. That's fine. Okay. So if I look at where the clock is now, I could just start a new one, right? I mean, I guess it doesn't matter. I'm gonna start a new project. I'm gonna call it live stream like this or else. Okay, just I don't know why. I just came to whatever. Okay, so the idea of a clock, right? So as part of a clock is a sensor, and it's a non-visible component. But remember, if you notice the properties of a clock, right? We have the timer interval, and hopefully we can read this. Okay, I'm blocking it now. So we have the clock interval over here on the properties. We have that timer always fires and the timer enabled. The idea is that when the timer fires, and it's going to fire every interval. The interval is in milliseconds, so it's going to fire every 1 second. So every time the timer or this clock fires its timer, right, an event is being triggered. Well, what event is that? It's the event of this. It's the clock1.timer. It's like, hey, when the timer goes off, this is, there you go. That is the thing that's firing. So this is going to happen every second. So I mean, how do you make a timer? I drag the timer over, and I see that this is going to happen well every interval. Well, what's the interval? By default, it's 1,000, right? Which is 1 second. If it was 5,000, that's every 5 seconds it's happening. If I want to make a 30-second timer, that's 30,000, right? And so now this is going to happen. This is going to go off every 30 seconds. Every 30 seconds, maybe the round is up or whatever in your game, and this is happening, right? So this is happening, people, whether you like it or not. This timer is going to go off every 30 seconds, and whatever's in here. Now it could be adding one, it could be changing the level, it could be whatever. But the idea is that that's all that you need for the timer. That's all that you need for our clock, right? You need a clock for the timer. The timer goes off every time, and so the way that we used it in our the way that we actually used it was in our turn off the lights. I'll just go to period 9. I don't know. Hopefully it does it. In our turn off the lights sort of app here, the way that we did it is I mean, this is, I think, a pretty light version of this, but that's fine. Um, is that, hey, look, here's our timer. Well, the timer's going to go off every, 1 second, because that's the interval. And every when the app is running, every 1 second this timer fires, and what happens? Oh, it calls this procedure. So we have a little bit of procedural abstraction in here. It's going to call this move random procedure, which won't expand unless I grab it. And what does that do? Oh, moves to a random it actually picks a random value from 0 to the length of the width, or the amount of pixels in the width, and from 0 to the amount of pixels in the height. It picks a random x value, a random y value, and then it moves that sprite to it. Now it moves the sprite on the canvas at that particular location. Yeah, remember that our light bulb is our sprite. We had our canvas it had an image in the background, but it was a canvas, and that's how you can move it around into a specific x, y coordinate, because we are a sprite. A sprite is a movable sort of over the background type thing. Right, Mario is a sprite, and the background is, well, it's the background. The sprite moves over it, so it's the canvas, so to speak. But the sprite goes on the canvas, and that allows us to sort of move it at any coordinate. And in this case, how am I moving it? I'm actually just picking a random spot and moving it to that spot every 1 second, because the timer's firing, this procedure is happening, and that procedure just moves it. And so that's what's happening with the timer. The rest of this just happens independently, right? If I click the sprite or touch the sprite, more stuff happens. A label's updated, a sound happens, a score is being included. Other things happen when you touch it, but for the most part, it would just keep on going, just picking a random location and going. And these are indeed pseudo-random numbers, right? That generates a pseudo-random number. If we're talking about pseudo-random numbers, you can actually make the pseudo-random number generator. You don't really have to know necessarily precisely how they work, because I mean, what formula makes them work, because again, they're all kind of different. But the idea is, so anyway, that was, someone asked about how sprites work, so that was Natalia was, I believe. So that is, I just mix it in right there as well. How a sprite works, again, it's just an image of something that is movable over a background. In this case, the background is a canvas. The sprite goes on the canvas, it can move around. That's how someone asked how a sprite works. So sorry, just making sure telling myself that I covered it, so I good. And that, which leads me also to PRNG, which is pseudo-random number generator, which is as opposed to a true random number generator. Okay, so a pseudo-random number generator is when I pick a random number. A computer program, again, typically is going to pick something that is, it feels random to us, it looks random to us, it probably might even be like in a normal distribution or whatever, like we would think of in a random number, but it's not actually random because it uses some sort of algorithm to do that. Right? It uses an algorithm to generate it. So it might use something like it's going to use something with a modulo, and I'm trying to avoid using that because I'm going to come back and talk about that in a second. But it uses a modulo and a modulus, right? It uses the mod, we just call it, which essentially is a remainder. So it does it starts with a seed, and then that seed does some sort of operation, mathematical equation or algorithm on it. Then it generates that random number. Then it uses that random, or quote unquote pseudo-random, but it uses that random number to then see. I couldn't do air quotes before, now I can. It does that number and it reinserts it sort of as the seed and does it again. So it's generating a list using its output as its input and going around, right? So it's generating sort of a list of random numbers. The difference here is that a pseudo-random number will eventually repeat again. It'll eventually come back around and repeat. Now, most computer programs are, um, and the way that they generate them are basically going to be generating the numbers in such a way that you'd probably never get back to the cycle. Like you probably might not never ever make it back around. You probably not never notice is what I'm saying. So pseudo-random numbers are great for a lot of things, right? They're great for models and simulations because you're just trying to generate sort of a variance of, you know, of how light or wind reflects off something, of atmospheric pressure. Like you're some sort of random. You're introducing some sort of randomness to a simulation, as opposed to certain things would need true randomness. Otherwise they could possibly be cracked or predicted because it uses an algorithm. I don't know if that made it more clear or less clear, but like things like encrypted things or sort of banking websites or any sort of secure website really, or like casinos would probably use something encrypted. Um, even secure web content would use an encrypted would use true random numbers for encryption. So you can do that. We'll talk more about that later. But for the most part, just know that there are things that pseudo random numbers wouldn't be good for that are part of that that true random numbers would need to be used for, that pseudo random numbers wouldn't be. But for most things, they're good. Okay, so that was, again, I'm just trying to make sure I hit those things. PRNG, certain situations. Again, you should know, like I said, that it's based on sort of a formula that spits out that, again, you have a seed and you can spit it out, like you spit out a random number, all that good stuff. Yeah, but basically, I think we hit the highlights of that for sure. Um, I'm going to tell you, people who are currently listening, all 36 of you, only 36. What are we doing, people? Um, Man, tell your friends or something. But 42, nice. Okay, so, but anyway, as far 34, what? Okay, something's happening. It can't be 7 people coming out. Anyway, doesn't really matter. I should focus. But the idea is that I'm going to tell you guys that you should definitely look at CodeHS. Okay. I mean, we can look at the topics here. I'm not going to go over them. In fact, I didn't even like complete these on the account that I just signed in for, my teacher account. I didn't do them. Um, but again, through 10 is all the way through for loops, right? So we should pretty much have understanding what comments are, understanding using abstraction, which is making procedures essentially, or they're called functions in Carol and JavaScript, but essentially that's the same thing. It's a procedural abstraction. Super Carol does something does different. It uses some abstractions already built in. We talked about for loops, which are repeating things. Um, designing things and the basic functions and of Carol and how you would type commands. So yeah, I would probably review your Carol work all the way from 1 to 10 there. I'd review it. I'd review it thoroughly. And to be honest, if you did it and did it on your own, you're probably going to be fine. But it's always good just to take a gander at. There it is that way. Take a gander at it. All right. And let's see. A lot of the the things are looking through your previous programs. Like I mean, I just took a look through my programs as well, right? I mean, I'm going through them. You're not gonna have all the variety, but you're gonna basically have the different variations, I should say, of these projects. But you should have your map tour, right? You should have your turn off the lights, your logo, and we called it flippin' something. Like I mean, my class called it flippin' and then amazing. We had flippin' trippin' hazy was period 9, flippin' annoying was period 8. Sorry, period 8. Truth hurts. Flippin' awesome was period 7. But again, you guys probably called it coin flip app or something lame like that. Sorry, everyone else. Um, but the idea is that it's a coin flip app, and so it uses, again, we can click on flippin' trippin' hazy, which is of tripping hazard is what we know it as in period 9. If you know, you know. Um, So we did a lot of this stuff. Now we could have definitely probably consolidated our code a little bit, maybe a little procedural abstraction because it's a little jumbled, but it does the trick. If that's okay. But the idea is we use these as for each loop here, right? Now let's grab a new one because I don't want to. So this for each loop here, right? We should know how that works, right? That's one of the things that was introduced in a lot of these, right? That was actually introduced in the coin flip and the logo app, which the procedural abstraction is involved there. So yeah, understand from to by what these numbers mean, and then things in here are going to be repeated. Okay. Um, I don't know. Okay, I don't know where to go from there. But let's see. What are models and simulators? What do you mean? What are models and simulators? Jed, favorite dessert is a good question. Again, the top. Sorry, I'm just working my way down a little bit. It's over here actually. It's on my screen over here. Um, But give me a second. So we did procedural abstraction, PRNG, good. Okay, so repetition are loops. Repetition is the same thing as a loop. This is a form of repetition. There are other forms of repetition. Going through every item in a list is a form of repetition. Going through a while loop is a form of repetition. Any sort of loop, right? Actually, these three are pretty much going to be our loops here. Any sort of form of iteration or doing something again is repetition, right? So repetition slash iteration is called the same thing, but doing loops is another word for that. It's just doing something again. So in this case, our for loop is here. This is a fixed repetition, does a certain amount of times. Our for each loop is also fixed repetition. It repeats the amount of times that there are items in a list, which we did a little bit of listing on the map tour, so you can check that out. And then the while loop, we haven't done a ton of this, but it basically keeps on going forever until some condition is met. Um, okay, so we can get rid of those. Wait, there's 4 blocks there. Yeah, there is. See ya. Okay. Anyway, so that was relation, repetition. Okay, and then selection or if statements, right? This is a big list right here is a selection sort of tree, right? It's if, else, if. It's an if, else, if, and then, right? So it has some selection to it, right? You're selecting your own you're selecting a path. If something is true, do this. Otherwise, do this, right? But then once you're down this path, if something is true here, then you go down another path, right? So it's a selection. You're choosing. I hope that was there. I don't remember. Uh, it's choosing. It's selecting a path. That's why it's called selection. So if statements typically for us are what we consider our basic selection structure. And then our loops, which is our for loop and all the loops, but for loop is the one we've been primarily working with. That would be our repetition structure that we got. Hopefully I covered the difference already between encapsulation and condensing. I'll cover my favorite dessert later. That's an important one though, obviously. Models and simulators, again, okay. Main topics of Code HS. I kind of went through that. I mean, as far as the main topics in Code HS, they're literally listed here. I mean, they're all main topics. So there's 10 of them. If you did them, you should be good. If you didn't do them, I don't know. I guess you should have done them. I'm looking at you. You should feel guilty because you didn't do it, did you? Did you? Don't lie to me. I dropped my pen. Okay. Okay, so I think everything is now down to models and simulators or simulations. If you look on our on the old internet, the website of Schoology here, um, you will see that, okay, yeah, blown to bits vocabulary is right there. Please look at it. Please look at it. But the idea, dang it, I better get my pen now. I dropped it. Where'd it go? Technical difficulties. Hold on, I don't know where it went. It fell underneath the thing. Ready? And we're back. Got it. See? It fell underneath the old computer. Okay. Um. So where are we? So if I'm looking again, we sort of there's a lot of the stuff to look through. Again, if you're having some trubs, that's what cool kids call trouble. Can I write on this? Is this gonna let me? Yeah, sweet. Right. Again, make sure you look at that. We got the study guide. Of course, you're gonna look at the study guide because that covers all the stuff that we talked about. Um, a lot of these were, relate to the privacy and blown to bits that you read or will read or whatever. Um, and Alexis in the chat there is sharing her Quizlet with the vocab on it. Always a good option. Um, I'd take her up on that offer. Uh, as long as you like this, as long as you like and subscribe, then you're allowed to have it. Otherwise, Alexis, don't give it to them. Okay. All right. Like and subscribe, or else she'll follow the rules. She's good like that. Anyway, so if we keep on sort of looking here, again, models and simulations we talked about, and again, the ones that we talked about were kind of here. We did talk about the 4-bit computer simulator and the assembler language simulator. I think we talked about it a little more extensively in my class than the other. I think anyway. I don't know, just from what I gathered. But that doesn't. It's not like you have to just know that what a simulator is and what it does and why it's cool. Not necessarily that. Alexa, make a note to buy Mr. Spitzig a gift. Okay. There you go. There you go, Jet. Okay. Um, anyway, as far as there were there were these. Uh, where is it? Simulators are cool. Anyway, so these are the simulators that we kind of looked at sort of extensively, but there's a bunch in here. You're gonna let me like use it, or is it just because I wrote on it? I'm not allowed to use it anymore. The internet is a weird place, everyone. I don't know, I'll do it later. But the point is that we again, this is a good definition of sort of models and simulations. But let's just real quick maybe run through the benefits of, because it even says right in the thing, hey, what are the uses of models and simulations, and what are the benefits of them? I mean, we could do a quick Google search right here, uses of simulations. I mean, if you wanted to. Uh, whoa, that's crazy. Yeah, he really. Yeah, face reveal at 50 viewers. Anyway, what was I gonna say? What was I gonna say? Okay, I'm not very focused. Sorry, guys. Um, okay, so I'm just thinking though a little bit now. This is a good article on pseudo-random number generators for gaming, how it works. Again, there's some sort of extra resources I'm aware of here. Um, Yeah, okay, we could just search it, right? If you wanted to just, so that was one thing. If you really wanted to just like, hey, let's look at the old Google. I mean, I'm not gonna, I know them, but we can be like, hey, what are the benefits of simulations? Look at all those different things that you can do with it. Cool. It gives you real life experiences without having to live through them. Do you guys really want to simulate like doing like having airline simulation for pilots where if you do a bad job that day, you crash? I don't think so. So the idea is it allows you to get so multiple uses. That's a lame one. There's no risks, right? You can I mean, these are kind of lame, but that's okay. But it gives you the idea of what they are, what's useful about them. Again, you can have simulations as far as uh, driving, or flying, right, to learn how to do things. So it allows you to learn how to do something without any of the risk, while still giving you the sort of the tangible sort of feedback. It allows you to to create something that you can change the variables on, like repeatedly. In other words, you don't have to. You can tweak something, right? Let's say you're building a model of a building. Um, like if you were building a building, right? And you wanted to test again if it was hurricane proof. Well, again, instead of building a thing and waiting for it to like have a hurricane and then test if that worked, and then if that worked, then build another one, right? That takes a whole lot of time. No, I can just tweak a bunch of things. I can test it on a category 1 hurricane, category 2, category 3, category 4, category 5, beyond that. Oh, it's standing, good. Now we can maybe make an actual physical model of it and test it, or just go, just understand that we tested it in the computer simulation and it worked out well, so we're good. So again, you didn't have to have any of the expense, so it's usually cheaper. You can change the parameters, right? You can just change all those variables and those parameters that you can be tweaking. So, change the wind speed, change the soil that it's sitting on, change whatever, right? So if you're trying to predict or model a hurricane path, okay, change maybe the air pressure, change the water temperature, change the current air speed. Is that a thing? I don't know. But you can change different variables that then lead to you to make predictions without you, and you can rapidly change those, right? Depending on new variables, new information, or just wanting to tweak it to see, hey, what would happen if the temperature is actually a little bit lower, uh, or the water is a little lower temperature than I thought it might be. Oh, it's going to go further north or wherever. Um, so it's super easy to change parameters, input parameters and conditions, right? That's actually a benefit. Um, and honestly, anyone can really run a simulation. Half the games that you guys play are simulators. I mean, you can run. There's a farming simulator that's one of the best-selling games, which no one, I mean, that people play. I mean, simulations of SimCity, right, is a simulation, right? These are more game-like simulations, but they're simulations on the left. So any computer can really run it. It doesn't take like a mega computer like mine to do that. It just take anyone can run them. Like you can run them on the web. They're simulations because they simplify a lot of things. They basically allow they simplify a process. The only um, and again, you can test things that you might not have ever been able to test before. What's it? Can we test the conditions on Mars? Well, yeah, we could. What would happen if we try to do to terraform Mars or whatever, and we throw out certain things and what would happen there? Nope, that did nothing. Try this. Maybe we can tweak these variables. We can change these parameters and these certain conditions. But we can do that obviously without sending things to Mars, which would be super expensive. And we can do it before we even think about going there, right? So obviously we need to be prepared when you got there, whatever. So we can think about it in advance. Again, there's a couple things that they have some limitations. Obviously, is that the model and simulation is only going to be as good as the variables and the programmer making it, right? They're only going to so in other words, like you have to. The world is complex. Things are complex. You can't plan for every variable, so there's no way to really make 100% accurate predictions with this simulation or model that you'd be making, and that's just simply because there's a lot of variables. In other words, you're going to have to simplify. There's going to have to be some simplifying sort of assumptions that you go into it. Like, okay, maybe I can't take in all possible factors everywhere, but I can simplify it down to maybe the main 5 factors. So I'm going to have to make some simplifying assumptions going in. So in other words, I may not be able to take into account all variables, so it might not be perfect. So that there's those. And again, you can sort of think about there's a lot of different ones and different ways to show models and simulations, but really it's just a computer doing some of the work by testing certain situations. Okay, so I think I answered that crazy thoroughly. Great, good job, me. I actually have played YouTuber Simulator. I don't think it's called that. It's called what's it called? YouTube Simulator game. A YouTuber's Life. Yeah, that's the one I played. So there, I have played it, and I'm super good at it. So there, Tyler. Um. Anyway, Okay, so I got a question about lists. I have Sarah liking and subscribing. I've got Courtney liking and subscribing. Tyler definitely liked and subscribed. Okay, so I got some notes to buy a gift for me on the people's Alexa. Pretty good. Pretty good. Um, what is it? What is it? What is it? So I think the only thing left is building lists now. If you want to do that, there might be some other things. Again, we did talk about a bit about code HS, making sure you're going through. Is that even the right one? That's not even the right one. Going through code HS and doing that. Let's see. Yeah, here they are. So again, all the way through 10, right? All the way through for loops, making sure all that good stuff there. Um, I'm just trying to hit the things before. I did talk about the clock. Yep, I did. In App Inventor, I talked about it. Not in this one, but it was a bit back. So turn back the clock. Okay, sorry about that. Sorry everyone. Apologize. I'll be better next time. Probably not. Okay, so let's see. What else? What else we got here? I said review the code HS. Where is this? Where's the document? We talked about code HS, the lights off app. Again, we talked about the sprites moving around on the canvas. Sprites have to have a canvas, right? Otherwise, they can't have an XY coordinate. The clock we talked about, sort of the clock is the thing that is triggering the event. In this particular case, it triggers events in general, right? When the timer goes off, it triggers an event that happens. It's an event, the event handler is handling the event of the timer constantly going off. So goes off, do this event. Goes off, do this event. Goes off, etc. And in this case, the event was pick a random number, pick a random location essentially, and put that sprite there on the canvas. Cool. Logo, we talked about that. That's a awesome procedural abstraction app where we sort of everything was kind of abstracted, whereas procedural abstraction was amazing in that app, but just generally speaking, because it encapsulates the code, it keeps it all together. It simplifies the code, right? It makes it easier to debug, easier to read, easier to use, and it condenses the code. It makes it smaller, makes it so that I can repeat things over and over again without copying, pasting, or typing them over again, right? So those are the three main things for procedural abstraction, but also in that logo app, it did a pretty good job of that. Coin flip app, we called it something different, at least my classes did, but that's what it does. That is a simulation. It's simulating flipping coins. Why is that better than flipping hundreds of coins? Because it's better than flipping hundreds of coins. I don't know. It totally is. Believe me. Um, I mean, it does it faster. We can do it. We can change the variables. Maybe you can make it so there's a chance that maybe a different coin has a chance that you end on the edge, and maybe you can see how many times it would land on the edge. I don't know. That'd be based on statistics, but still. Map tour again, coming back to lists. I know lists. I didn't forget about it. I'm going to do that. I just want to get through this list to come back to the list. Listception. Okay. Yeah, we talked about procedural abstraction. Please, there's some Quizlets floating around on the internet. If you haven't found it in the chat, make sure you can it only lets you view it though if you've liked and subscribed to the video. So make sure you do that, and then you can totally get that Quizlet. Um, yeah, and then pseudo-random numbers. I think we talked about that. We just talked about models and simulations. Modulo, again, modulo is one of those things that you want to make sure that we definitely understand. And again, the idea, remember modulo sometimes written like that, but we typically just write it using mod or the word modulo, right? Is my face in the way? My face is always getting in the way. Okay. So if I had something like 10 mod 3, right? The result of that, like as a block, would be 1, right? Because if I did 10 divided by 3, well, that's, 3 with a remainder of 1. And so it's that remainder that actually this modulo gives me. Dang it, it's in the way again. All right, I'm over here now. Okay, so it's that remainder of 1 that the mod is. So you could do multiple things. You can do multiple mathematical operations, right? I could have, 5 plus 3 mod 4, right? Wow, am I doing? Okay. So 5 plus 3, mod, in parentheses mod 4, well, that's going to be 8 mod 4. Just we simplify going across. 8 mod 4, well, 8 divided by 4 is 2. So there no remainder. So that has a remainder of 0. So 0 is going to be what I was looking for there. 0 is the answer. That's not what I'm looking for. I don't know. I'm not really looking for any number in particular. I like all numbers equally, people. Okay? Except for 19. Ugh. Okay. And then if you have having trouble converting hexadecimal binary conversions, I believe I did my live stream on that is somewhere. And again, I flew off the screen. Is somewhere you can look at. Again, you can spend a lot of time doing that, but I think I did that in previous ones, so you can check back those. I felt very, very good about those videos. They're quality work. But anyway, they at least go through the basics of them, and you can, if you have any specific questions on them, shoot them in the chat now. But again, you could definitely look back at those now. Don't go now, okay? But later. Okay, so I got a question. Someone said, is assembler lower level code or higher level code? Assembler, okay, lower level code. Then what? I guess would be the question. Okay, because really that answer could go either way. And because really, remember we talked about assembler was actually easier than binary, right? So it's like we have the lowest level language is basically, ones and zeros, right? It's binary. Right? But then we can group these. I think I did too many, but we can group these then in sort of in our spectrum here up to higher level language. And these are higher level language, and why would that do that? Higher level language and higher levels of abstraction as well, right? The higher level the computer programming language goes, the higher level of abstraction there is. So we're grouping every group of 8 ones and zeros into some sort of, you know, add a or whatever, right? Like we're making that sort of group together, and that is sort of assembler. In other words, it's a higher level of abstraction than binary. But as far as like what we have, like App Inventor, like block code, where we're just dealing with like our full blown for loop of whatever, like 151 whatever. Like we have our actual blocks and things in here for each. I don't know, but like our block code here, right? I guess I could write it over here. Our block code is like super high up, and then like text based, like print. I'll just write it print statement or whatever, blah blah blah. Right? So that's like our text-based language. So like depending on what you're talking about, is text-based higher than block? No, it's lower than block. Is text-based higher than assembler? Yeah. Is it higher than a binary? Yeah. Is assembler higher level language than binary? Yep. Is it lower level than everything else? Yes. So to answer your question, depends. Um, okay, we can do one of those too, Elena, in a sec. Just give me a minute for that. Um, I gotta do building lists. Um, lists that we have to do. Wait, what did I want to do? That was a good question, and it led me to this. Um, yeah, so we can go over one of those. I wonder if I can find one that we've done, so I don't have to like find one. I don't know. We did mod already, right? Um, I just want we talked about models and simulators, right? So as far as simulations go, if you want a reliable result, the more times you do something, the more you can choose. Because if you do a simulation one time and it's like, oh, the hurricane's gonna smash right into us, okay, but then I do 100 more simulations and every other one of those simulations goes up and flares off into the Atlantic, it's like, well, obviously that's probably what's more likely going to happen. So the idea is the more times you run a simulation, the more reliable it's going to be, the better results you're probably going to get like overall. So like that's why simulations are ran on computers, because I don't have to test them 1,000 times in real life. I can actually just because maybe that was an outlier or whatever, but I can test them a million different times and see of the million times 89% of them said this is what's going to happen, so you probably think that's what's going to happen or whatever, right? So the point is that the more times you test a simulation, sort of the more reliable you're going to get. And we talked about random events versus like true random events versus pseudo-random events, right? Like flipping a coin is basically what we use to is a random event, right? There's so much like air pressure, and flipping, and how it hits the desk, and so there's like that is basically a random event, right? Like nothing else really is too random. It's I guess if you shuffled like a deck of cards and you picked a card out, that would kind of be random because shuffling does mix them up so that no one really knows the order, so that it would be considered random. Uh, if you were to like, I don't know, like roll a dice, that would also be a random event because there's so many true things that go into that you couldn't predict. If you can predict it, it's not a random event, obviously. Um, let's see. I'm using the sheet to go through them. A list I'm going to come to, so I put that. I'm doing a list in a second. We talked about again, I would look, we did this, as far as drills go, that's a good way when we talked about outputting things. Again, we've done that a lot, but let me just actually pull that up if I can recall. Was it here? Where like because in our program, right, this is one of the things that we wanted to make sure that we knew how to do, and that was, again, we just wanted to output, right? We wanted to output to a particular label or a particular button or wherever we're putting this, we're outputting, but we had, the way that this works is that we're outputting line by line. So this is going to say output colon and then the slash n makes it go to a new line, right? And then heads is going to stay on the same line with the get num heads. Then we go to another new line, then it says tails, and then on that same line is this. So until we go to a new line, it'll just all run into the same line. Actually, reading it this way, it'll all run in the same line. So that's sort of how that output would work there. We did talk about loop, reading the loops and what the for loop numbers did. Remember, selection is an if statement, right? Typically is when you're selecting between something. So if there's not an if statement, it's probably not selection. If there's not a loop, then it's probably not repetition, right? Repetition is doing something over and over again. Selection is a path, a choice. If something is greater than 7, do this. Otherwise, do this, right? It's a path, right? You're selecting between two things. If something's true or if it's false. If it's true, you go one way. If it's false, you go another. That's why it's an if statement, because literally you're thinking, if this, then that, then something. If something else, then go the other way. Or if not, then go the other way, essentially. So so the idea is selection versus repetition. We know what those are. Again, converting is always a great thing that we've been doing. Conversions, code HS. Yeah, we're pretty, yeah. What else? Actually, I'm not on the chat, so I don't know. Maybe you guys are saying a bunch of stuff. Lists. Oh, and then tracing the values. Tracing the values, and I think we are good here. That makes it a cool 1 hour of entertainment. Where is it? I think it was on the Word doc that I was writing on. Yeah. So we did that. Okay. So as far as actually, you know what? Maybe we should just look at the list. How you'd make a list. We made a list on one of these projects. It might be a little complex on some of them, but if we just start on I'm just gonna go back to this one right here, because if I was building a list, right? If I wanted to add 10 items to a list, yeah, I'd make a for loop that went from 1 to 10 by 10s, right? So that's going to be a 10 items, and I would go to lists and I would add items to a list. And so when I'm adding an item to a list, I need to first have a list, so I'd make a list, and I just call it the list. And what I would do is I would just make it a empty list. Now, you're obviously not going to be dragging things around on the multiple choice test because that would be weird. I don't know even what you do, But yeah, if you saw this, you're like, oh, I made a list. It's an empty list, and now I'm making every time the timer goes off, I'm going to add 10 items to this list. What items am I going to add? I don't know. Let me add the number to the list. What list am I adding it to this? So literally every 30 seconds, I'm going to add 10 items to this list, and there it'll be the numbers 1 through 10. It'll add 1, then 2, then 3, then 4, then 5, then 6, then 9, 10, and then it's going to do it again. It's not going to be a very entertaining program, but this just shows you, yep, it's a loop. Yes, it's adding the items to the list. It's going from 1 to 10 by 1, so it's 10 times. If I did 1 to 10 by 2s, it's going to be 1, 3, 5, 7, 9, and not 10, so it's going to be 5 times. And so it's going to do it that many. So the by is just counting what you're counting by. If I did from 1 to 10 by 3s, right, it'll be 1, 4, right, what do I do by 3s? 7, and then 10, so it's going to do it 4 times. And what else? Okay, so know how the loops work, and then that's honestly the last test had more about lists, and I think we'll use more about them later, especially when we do some of our drills coming up. But the main idea is, yep, you can add. How do you add items to lists, and how do you get items, select items in a list, right? Well, you add them using the add items, and again, that's going to be putting this item in this list, adding it to it, adding to the end of the list basically, and then if I want to use it somewhere, I'm going to pick a list, and I'm going to pick a specific item in the list. And the index, remember, is the is not the item itself. It's not like the word or the number that's saved. It's the index of where it's saved. It's the number of the item that it's saved. So the first, if I wanted the first item in the list, the index would be 1, right? If I wanted the second item in the list, so if I wanted the first item in the list, the index would be 1. If I wanted the 10th item in the list, the index would be 10, saying, hey, give me that 10th item in the list. And what list? In this case, it's the list that I called it. Okay, so hopefully that's a good uh, situation there. That draws a line for each side from blah to blah by blah. You mean the for loop that I just went over? I'm not sure if you said this before I just spent the time going through the for loop or not. Can you just clear that up so I don't redo that again? I wasn't looking at the comments when I was going over it, so maybe you asked before and I covered it. That would have been cool. All right, so the trace the values thing. But that's basically. Still going back to that. Okay, so the idea is that we did a little bit of this as a review, but again, the arrows just mean that I'm storing a variable, right? So we did this where it's like if I did this, oops, I blocked it. If I did that, right? The I this is weird pointing that way. Anyway, if I did that, right, over there, and I was looking and I'm just gonna trace this, right? Well, the idea is there's 3 variables here. This first one says, hey, our variable A is going to be, I'm going to do a different color. Our variable A here is going to be 3. Okay? Because that's what it says. Is we're setting 3. The value 3 is being inserted or put into A. Right? It's changing A from whatever it was before, which was nothing, to 3. All right. Then we have B. B. I don't like this weird pen. This Galaxy weird looking pen. We're going to change it. I mean, I kind of like it, but it's hard to read. Okay, so B is now 4. Well, C, it's A plus B. So we do A plus B first, and we make it C. Then we're changing A to what C is. So A is now changing. It's no longer 3. It's now what C currently is, which is 7. Then B changes to what A is. So B is now changing to what A currently is, which is 7. Right? So it's like we're going through this and we're checking them off as we go. And once we've done them, we don't go back, right? So once we've done them, the variables have changed and we're going to just step through them. And then we're changing, we said did this, A is C, and then we did B is A, and then the last one says we're going to change C to B plus C, right? Well, C is 7, B is 7, so B plus C is 14, so C changes to 14. So if it asked you for what would be A plus B at the end, it would be 14. If it asked you for what was C divided by B, it would be 2. If it asked you for what A, B, and C are, it's 7, 7, 14. Right? So the idea is just assigning variables. So just keep track of them as you go, and you'll be all right. What do you think about that? Check my Xbox controller I got. It's pretty sweet, right? It's got the green trim. Pretty nice. It's pretty good. All right, I'm trying to read these things here. Yeah, we probably covered everything. So if you forget something, well, that's on you, but maybe go back and watch the stream again, especially my classes are 7, 8, 9. Plenty of time to watch the stream again. Maybe log in from a different account, like subscribe. I don't know, something like that. Actually, it really doesn't help me or matter to me at all that you do. It just makes me feel good inside. So it matters to my self-esteem, but it doesn't really matter anyway. So, um, you like the white controller? It's gray though. It's a gray controller. I think I have a white one somewhere. I have a black one too. Here's the black one. It's just normal. It's a normal black one. It's charging. Um. All right. So reading through, I think I got the questions down. So I probably would just, I don't know, play or just maybe go to sleep, do something quiet night or something. Probably not do much. Um, Hi Sarah. Hi Elena. So I don't see any other questions. I did explain random numbers already, so if you want to uh, rewind, turn back the clock, already made that joke earlier as well, so you get to relive that one. Yeah, I did them, totally did them. Yeah, but don't worry, it's recorded through the magic of the internet. You can rewatch it again. You can even rewatch it at like 3 times speed or 0.25 speed if you want to savor it. Just want to take it in, take it to heart, you know? Um, so Courtney's not getting any extra credit. Just as like a side note, completely random. Um, just like maybe take an informal poll here, guys. How many screens would you say would be an appropriate amount of screens to have in a normal functioning app from App Inventor? You know, one, right? Yeah, that's what I thought. Yeah, yeah. Just one. Maybe two. Maybe two. Certainly not four. I'll tell you that much. Oh, incorrect answer, Courtney. Incorrect. Okay, so I'm happy to hang out here a little bit and answer any questions that you guys have. Um, I mean, any other particular ones? Otherwise, again, I think a lot of the stuff, I almost all the stuff I answered at some point. I felt like I jam-packed it pretty good. I was only off task a few times, but in sort of in a hilarious kind of lost kind of way. So, so it made sense. So it was good in the context of the live stream. Um, let's see. So feel free to, yeah, definitely go back and watch it. Again, it'll be posted and you can check it out. Otherwise, again, I'll be right here for a few moments. We talked about the list part of the Map Tour app, or we talked about lists in general, but we didn't talk about the Map Tour one again, but we did talk about it. Yeah. I didn't talk about it in depth, but again, I did talk about the list part, which is the main thing about that one that we did. Is this loss? Is that a meme that I don't know about? I feel like I can't tell the difference sometimes between typos and memes that I haven't heard of before. Oh, everything is going to be rigorously timestamped in the YouTube video. And by rigorously timestamped, I mean I'm not going to do any of that, and you're going to have to just flip through it and see, because I totally didn't. Sorry. I don't know what time. It's 9:41. It was within the last 1 hour and 8 minutes, though. I'll tell you that right now. Uh, I no, that wouldn't be very useful. That would just get you guys distracted when really you just need to. Do you want me to? Should I stream YouTuber's Life 2016? I'm gonna get demonetized if I play it, guys. Come on. How dare you? How do I get rid of this pen business? Nope. Stop. Oh, there you go. No. Nice. All right, Elena, I will cancel the tests for my classes and give out hundreds. You're on your own, though. Sorry, you gotta tell Miss Saunders. Wow, Alexis is the greatest mod of all time. She's like 10 mod 3, because she's number one. You know what I'm saying? That was a moderator, modulus joke, but also worked in to the answer was being number one, like she's the best, but also because that was the actual answer of the mod. See, it was good. It was great because it worked on like a few different levels. So Ethan said Schooly. He said the notification bell on Schooly. Nice one, buddy. Wait, what do you mean the notification bell? What's going on with it? Oh, is it? I don't know. What was it? Was it doing? Oh no. Oh, this one? Oh, 'cause you're saying that there's a lot of notifications that I haven't ever looked at. I didn't even know what that did. It's all the classes together too, so that's why I really look at it because it's all 9 or 8 periods that there are Miss Saunders and I together. So is that better now? What's Minecraft? Is that a some sort of game? I need one of those cool ring lights so that I, look super cool. Wait, did that light just turn off back there? Did that light turn off in the background? Don't worry, I gotcha. Turn on the living room lights. Nailed it, right? Sick, huh? Dim them to halfway. Okay. What's the time now? Oh, you're saying Alexis. Just say, Alexa, what time is it? It works. I think my screen was brighter before. That's why it was giving me, because it was the white. Yeah, see? It was the screen. Wait, you mean period 8, like this period 8 right here? That period 8? Oh, my background moves because I use what's it called? Live wallpaper. I think that's what it's called. You can get it through Steam. It's like $4 or something. But you can put a bunch of different stuff. But obviously, I have the Gator one. What else we got going? Oops. Okay. What was your question? Oh, I already answered it. Yeah, one of those. That's what I need. No, I want like an easy one. Yeah, that's my camera right there. Webcam ring light. That's what I'm talking about. Ooh, 2? Seems a little excessive. Haha, ring. All right. Wait, is a question about hexadecimal RGB lights in the back? Well, we know what to get me for Christmas then. Boom. My computer is RGB. You can't see it though, because it's down there. Guys, I'll have you know that there's 147 playbacks. And I don't know what that means, but I think that means people hit play 147 times. So we never hit that many concurrent viewers, but I believe that means people tuned in 147 times. I don't know if that's unique or not, but if it is, that's pretty good. That's nearly every person who has in comp sci principles. It says the audio stream bitrate is 0, which means you probably can't hear me, or it's coming through weird. So wait, what did you get? Sorry, I was just looking at my device manager real quick. Oh crap, I can't see anything. Where is it? Let's get rid of this. Okay. Oh, sorry about that. I couldn't see it. I think it's under system. Oh, whoops. You can see my 32 gigabytes of RAM. So, sorry. I mean, again, you guys know what to give me for Christmas. RTX 2080. It would work. If you want to get me dual one, seems a little excessive, but I'll accept. Thanks. Um, you're welcome. Hey, don't spend that all product key in one place, okay? But seriously, don't, because I need it. Are there any actual questions? Because I feel like I might, go to sleep at some point. I just finished downloading. I mean, I'm gonna go to sleep, but it downloaded. Boom, Jedi. Fallen Order. By the way, guys, on a side note, again, since we're seriously just making the stream extra long for people who are going to watch it tomorrow, but I was hesitant to watch Mandalorian, The Mandalorian. I think this was The Mandalorian or Mandalorians. No, The Mandalorian. Yeah, it's pretty good though, and honestly, it's because of Baby Yoda. Yoda, super cute, right? Baby Yoda. I mean, I want one. Oh, me too. 100%. Like, I totally get it. Like, when that one robot was about to shoot Baby Yoda in the face, not cool. He got what's coming to him. Yeah. I think I want this. I want a Baby Yoda doll. Oh, creepy knockoffs. No, I want the official one. That is, come on. It's Baby Yoda. Oh man, do you think my stream just got demonetized because I looked up Star Wars stuff? Dang. Courtney, do you think that this is the end? Do you think that this is the people staying to the end? Don't think so. Oh, thanks, Max. Okay, we've hit 151 playbacks. I think I can officially go. How are 36 of you still on? I haven't even answered a question in like 15 minutes. What are you guys even doing with yourself? Shouldn't you be studying for something? I'm just sitting here talking about Baby Yoda. Good night, everyone. Good evening. Anything else that's sitting around that I can show you? No, that's lame. What else we got? No, nothing really. My chair's squeaking because I don't have an Elite gamer chair. I'm not even sponsored by. I'm sponsored by Elite wooden dining room table chairs. It's made of real wood. So there. Oh man, who would win in like a battle or like just generally speaking? That's tough. I think they honestly would. I was just actually thinking to myself, would I care half as much about the Mandalorian if there was no Baby Yoda? No, is the answer. Would not. They know what they're doing. Disney knows what they're doing. How old was Yoda when he died? Does anyone know? Because if he's 50 and a baby, 900? Is that legit? Did you just make that up? Is that a guess? I need to know if you're being serious. I guess we could look it up on the internet. 900. Exactly 900? Seems like a little rounded to me. And if we're rounding, I just say, yeah, Baby Yoda's 50. That's what they said. So I'm saying if you're a baby until you're like 3, right? So that means at 100 he was like 6. So 900 he was only, what did I say? He's only 54. But he was super old, right? So I don't know this aging process of the Yodas. Is it what is species is he? Is he just a Yoda? He's Yoda, but like I don't know. One dog year equals 20 Yoda years. Is that actually true? No, I don't know. That would be more. It would be like it's like 25 Yoda years is one human year. 7 dog years is one human year. So it would be like 7 times the amount. Like the dog years to Yoda years would be way off. It would be the other way. Like if you had a, think about this. If you had a 20, let's say you had a 10-year-old dog. All right. Hold on. You had a 10-year-old dog, right? Well, so this is 10 dog years, right? And we know that, we have 7 dog years for every 1 human year, right? And we know that there are, for every 1 human year, right? We have 25 Yoda years, okay? Exactly 900? Again, I feel like that's rounded. Wait, so how many? So we have 70, or is that actually, did I do that math right? So this is what we start with. 10 dog years, 7 dog years for every 1 human. Should be on the bottom though. This other way around. I gotta flip it. Dang, anyway. I was just speaking out loud. You guys were not correcting me. What good are you all, you guys? Okay. So we have, it's 1 dog year. Wait, yeah, 1 dog year is 7 human years, right? And then set 1 human year is 20, 25? I'm going to say 25 Yoda years, right? There we go. So it's 70 times 25. Right? So if my calculations are correct, again, I think it's 7 times 25. And if your dog was 10, wait, that's plus. Come on, people. Get it together. So if your dog is 10 dog years, all right, is the equivalent of 70 human years, which is the equivalent of 17,500 Yoda years. So I'm saying if you had a 10-year-old dog, that's the equivalent of Yoda at half his age when he died. Okay? A 5-year-old dog is the equivalent of Yoda. Yoda died young. Only the good die young. Billy Joel said that. Whoa, look at Samantha coming in with an actual question. All right. I guess I'll have to do this actual question now. Thanks a lot. Okay. I mean, how would I draw a line? Yeah, it was fun while it lasted. Okay. Um, I mean, I think I did is essentially explain like drawing a line is just moving forward. I mean, that's all that it is, right? So I mean, if I'm looking at in App Inventor, it was the logo one, right? So if we look at the logo one, right, there's a ton of stuff that we did. But I mean, when we first started, it was if you just move forward, you draw a line. I mean, that's it. If you wanted to draw a longer line, you just repeat forward. That you just you repeat the forward command 10 times, 5 times. So you just use a loop essentially. And again, yeah. I mean, it would essentially be using that loop over and over again. Yoda doesn't die. He transcends to a Jedi spirit through the Force. I didn't spoil Star Wars. Come on, you had to know. Gordon, you had to have noticed Star Wars. Again, I didn't ruin Star Wars for you. That's what The Last Jedi did, and it ruined it for all of us. Okay? All right. All right, anyway, people. I think it is time for me to head out. Good luck studying. Make sure you study those words. Quizlets in the chat. I think you should be able to access that. Someone put it up for you. I think Alexis made it. I don't know. I think she was the one who made it. Smash that like button. Subscribe for a good time. Learning about some computer science, comp sci, I was going to say, and then I elongated it to computer science. Sounded weird. Okay, just so we know. Anyway, I just did my outro, Samantha. Now you're going to make me answer this question again? Okay. Um, so how do you make the loop stay forever looping? Okay, so you're talking about a loop that goes on, that doesn't have a direct end. So a for loop is a loop that has a fixed repetition. So you wouldn't use that one. That's going to go a certain amount of times. If you want it to go on forever, you would need a while loop, right? And it's the condition that you would need. It would last forever, right? So a while loop would be like, hey, continue as long as 5 is less than, or if x is less than 5 or whatever. And if it never is less than 5, it'll go on forever. If it eventually gets to above 5, or if it gets to less than 5, whatever I said, then it'll stop, right? So that'll be a loop that doesn't have a definite ending. It's called a while loop, and it is sort of a conditional repetition. It repeats until a condition is met, as opposed to fixed repetition, which is a for loop, which is both are types of repetition, right? But one's fixed, which is a for loop fixed amount of times, and one's a conditional, which goes until a condition is met. Yeah, this is over. It's over now. I'll catch you in the next one. I need a outro phrase, guys. Um, thanks for watching. Make sure you watch my last video and the cards at the end of this. Is that a thing? I don't know. No, let's find a better one. Tony and I said hello. Yeah, 4 screens on your test. Perfect. That's the right amount of screens for you. Not for anyone else though. How about keep on coding? uh, you coders for life. I'm out. Um, Comp like that. That's pretty good. I like that. Comp out. Boom, nailed it. I think that's a good one. I'm going to use it. I'm rolling with it. Guys, ready for this? Ready for my outro? I mean, I'm not gonna put these cards up. Look, I'll just show you. Like, hey, look, there's a Be Right Back one. We got this offline one. We got the stream ending one. I'm gonna cut it. I'm just gonna straight up cut it straight from me. Um, and it was what? It was Compsci out. Oh no, I had to click this button. It kind of lost it, but that's okay. We're good.